Hey everyone, this is Evan from First Updates Now, and I am here with Team 9496 Lynk from Forest City, North Carolina. They are a team that has done absolutely fantastic this year. They have gone out of state for one event, they won it. Asheville, they won it. This is a rookie team that has been absolutely killing it this year. We'll be diving into their robot, their control system, their design and strategy, and what went into making this machine awesome.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
So going off to Nathan first, if you can talk a little bit more about how you guys went with strategy of going with this archetype and what you did that way.
So basically, we were looking at a speedy, fast shooter build for our main thing. We looked at mostly what could we do this season and what the robots would look like at the finished product. So basically, we said we're going to do a shooter build. So we made a fixed angle shooter with an under the bumper intake. If you like to come over here. Under bumper intake was actually an iteration. We were thinking about going over the bumper at first, but then realized how feeble it might be, like going outside the bumper. So we put it inside a little bit for the protection of this, but not fully inside. So as you see here, our swerve and our bumper, it's in between. So in between the bumper and swerve.
Awesome.
And so we basically made a fixed angle at 50 degrees. And it worked perfectly to make the shooter, and that's about it.
And then why did you guys decide to go with a fixed angle versus a adjustable angle? I've seen a lot of other teams go with.
We mostly chose the fixed angle mostly because it was very simple and we wanted to have a really simple robot, so it was easier to iterate and to improve on. And we chose 50 degrees mostly because it was the angle that worked the best for a robot.
Awesome. Going to pass over to Annalisa to talk a little bit more about how this robot actually functions. Take it away.
So how we are able to do a fixed angle is by changing the speeds of these different wheels. So by making one faster than the other, we can change the angle of it shooting.
Awesome. And so for your intake, what are you doing with that? Because I know under the bumper, do you have multiple rollers? How does that kind of work overall?
So we have two axles right here that pull it up here and two flippers that push the note into the middle so that, it doesn't get stuck right here.
Okay. And then I see it looks like you have some grip tape and some rollers. Can you explain a little bit more on why you went with that?
So we added this because this axle makes one of these spin a different direction, so it sucks it up. But a whole bunch of notes were getting stuck in between these two.
Okay. And
so we added that just so it didn't grab on.
Awesome. And what type of motors are you using for your shooter and stuff like that? Okay. Gonna pass over to Jane to talk a little bit more about the programming that went into making this thing work.
Okay, so on the programming side, we used a lot of custom software. So I'm going to start at the vision first. So at the front of the robot here, we have a orange pie. It's a custom solution. So, we are an Open Alliance team, so a fellow Open Alliance team, 6328 Mechanical Advantage. They listed what they used last year for their vision system. We kind of just copied that over. This is an Arduino Cam OS 9211. It is a global shutter cam, which means like the frames don't lag in between. And we are using Photon Vision, which is an open source project for vision.
Awesome. And so I've seen you guys shoot from multiple angles, even with a fixed angle. So can you tell me a little bit more about how the tuning went into?
We are away from the speaker from our vision, and that basically feeds into a shooter table of already tuned values. So like 6 feet is this much, 7 feet, 8 feet, and then we have like some special tune shots. So amp shot. These bottom flywheels actually spin a little bit more. We can demonstrate that real quick if Nathan will feed that through. So By making the bottom of flywheel fly faster than the top, you make it kick outwards. So that's how we're not able to have another mechanism for our amp.
Awesome. And do you guys have any sensors or logic you're using to detect where a note is when it's in your robot?
We have these two photoelectric sensors right here. We used to have just one, but this is kind of like a dead man switch. So if one goes out, the other still works. These just detect whenever we have a note, and the LEDs on the front of the robot change colors. So they'll change to what's supposed to be note yellow or orange when it has a note, and white when it doesn't. So it's easy to communicate to the driver if we have a note, because as you can see, this is all smoked out.
Yep.
So you can't see that easily.
Awesome. And one more thing, for autos, I noticed you guys have a really consistent 4-piece. Kind of what's your process for designing for auto?
So we use Path Planner. We have very limited space in our facility, so we can't really demonstrate like a full field. So we draw most of our autos up here in Path Planner. So Path Planner allows us to just draw up an auto easily and test it like live, and this makes it easier for like commands and stuff. And it just works out really easily. We're planning to use maybe Choreo, which is a trajectory generator, but that's more of a states or world type of thing.
Awesome. So that was Team 9496 Lynk on Behind the Bumpers. They have been absolutely killing it this year. They have 2 blue banners, and they are currently ranked 1 in quals. So it's going to be an awesome event for them, and I wish you guys the best of luck in competition.
Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.